Hello, today we are going to be talking about square roots. What is a square root? A square root is a fancy way to say what is the number that when multiplied by itself gives you that value. So if we look at square root of 4, what we have here, you ask yourself what multiplied by itself is going to give you 4. So what number multiplied by itself is going to give you 4? And so in this case, we know that 2 multiplied by 2 equals 4, and therefore the square root of 4 is equal to 2. We know that 4 is a perfect square because the values that create 4 do not have any fractions or decimal places. That being, the answer is not 2 1/2, 2.22. 4 is a perfect square because the value is a whole number of 2. The square root relates very closely with exponents. If you need a refresher in exponents, I will link a video in the description below where I go into details of what an exponent is and how to work with them. But all that to say is the square root of 4 can be rewritten as 4 to the 1/2 power. And that again is equal to the square root of 4. You might see them written in either form, but they are both equal to each other. Now back to our problem of the square root of 4. We know the square root of 4 is equal to 2. Now to check your work, you need to do 2 squared, right, which is 2 times 2, equals 2 times 2, which equals 4. But because we know the answer has to be squared to equal the initial value, we need to take into account negative numbers as well, because negative 2 squared is also equal to 4. As you know, a negative multiplied by a negative will yield a positive number. And because of that, the answer is not just 2, the answer actually becomes plus or minus 2. And plus or minus 2 states that the answer is plus 2 and minus 2. Instead of writing it this way, you typically see it written plus or minus 2, which again is just stating two answers of a negative 2 and a positive 2. If you need a refresher on multiplication and sign rules, I will also link a video in the description for those who are interested. When dealing with square roots, it is very useful to try and remember what the perfect squares are, and typically up to 15 is a really good rule of thumb. So 1 squared is equal to 1, and therefore the square root of 1 is equal to 1. Similarly, 2 squared is equal to 4, therefore the square root of 4 is equal, and you can move down the line. This is useful because if asked to find an exact value, you will have a good starting point based on the numbers you already know. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225 are all perfect squares because if you take the square root of each of those, then you're going to get 1 through 15. And so I would implore you to try to remember those values, again, because it's going to be helpful for when you are trying to solve for an exact value. For example, say you're trying to find the exact value of the square root of 40. Because we know the square root of 40 is between the perfect squares of 36 and 49, of 6 and 7, we know that that's going to be a really good place to start. Let's just try to do 6.5. So if we do 6.5 times it by 6.5, that's going to equal 42.25. We know that's a little high, but we know that it still can't be 6 because 6 is 36. So let's go between 6.5 and 6. We can try 6.3 times 6.3, and that answer is going to give us 39.69. And that actually rounds up to 40. So you know you are very close. You could go further to try to get an exact value, but typically you're not going to be asked to go past the first decimal place. But if you do, then you know that this is a little low because we're at 39.69. So what we can try to do is go to the next decimal place and go up a little bit. So if we do 6.32 times it by 6.32, then we know multiplying those together is actually going to give us the value of 40. By understanding your list of perfect squares up to 15, we had a really good starting point for the square root of 40. From there, we did trial and error. We started in between 6 and 7 because we knew that 7 is too high and 6 is too low. We went to an average to see if that was too high, which it was. Then we went to a lower number to see if that was too high, and it was slightly lower. So if we want to, then we can go, which is what we did, to the next decimal place and multiply that out to see if we can get a more exact answer. And we know that 6.32 is the square root of 40. Now remember, it's not just 6.32, but we have to do the positive and negative value of 6.32. And the reason why is because if we do 6.32 squared, that's going to give us 40, which is correct. However, if we do a negative 6.32 squared, you're also going to get 40. Be cautious and remember that you need to do the plus and minus to get the actual value of the square root of 40. Now, typically, problems are not going to ask for an exact value. I'd say 95% of the time, they will ask you to simplify down the values under the radical to as low as possible. So if we are looking at the square root of 40 again, we ask ourselves, are there any factors of 40 that are a perfect square? We happen to know that 40 can be broken down into 4, which is a perfect square, and 10. Now 10 cannot be factored down into a perfect square because its factors are 5, 2, and technically 1. We have our perfect square of 4, and then we have a remainder 10. Because we know that, we can break this down to the square root of 4 multiplied by the square root of 10. We know that the square root of 4 is 2 because it's a perfect square, and then that leaves us the square root of 10. We know that this is our answer, but we have to be very cautious and remember to put the plus and minus there. And after you put the plus and minus, this becomes the correct answer. And this answer and this answer are the exact same. This 6.32 is an exact answer, and this is a reduced answer, but they do equal each other. Okay, let's look at another example. Okay, let's look at the square root of 200. We're asked to simplify this down. We ask ourselves, is there a value within 200 that is a perfect square? We know that 15 times 15 is 225, and we know that 14 times 14 is 196. We know this is not a perfect square. However, if we take our factors of 200, maybe we can find a perfect square. We know 25 is a perfect square, and we know 25 can go into 200. So if we factor this down using 25, then 25 times 8 is going to give us 200. We also know that 8 has a perfect square of 4, and what's left is 2 because 2 times 4 is 8. With this information, we can then simplify our value under the radical. We have the square root of 25 multiplied by the square root of 4 multiplied by the square root of 2. We know that the square root of 25 is 5 multiplied by the square root of 4 is 2 multiplied the square root of 2 is not a perfect square, so we're going to leave that under the radical. From there, all we need to do is simplify. 5 times 2 is 10 multiplied by the square root of 2. Don't forget, this is a plus and minus, and because of that, this gives us our final answer. Now, again, if you wanted to do the check, you would do positive 10 times square root of 2, and that value squared, and you would do negative 10 square roots of 2, and then that value squared, and that's going to be equal to 10 times 10 is 100. The square root of 2 times the square root of 2 is actually equal to 100 times 2, which is equal to 200. Similarly, we have negative 10 times negative 10, which is a positive 100. We have the square root of 2. We have the square root of 2. And then that equals 100 times 2, which is equal to 200. So again, the exact same value, which is how we know that this answer is correct. Okay, let's look at one more example using variables and numbers. All right, looking at our last problem, we have the square root of 400x to the third y squared. We ask ourselves, is 400 a perfect square? Well, from 1 to 15, it doesn't seem so, because 15 times 15 is the highest one that we know, and that's 225. What we can do is try to factor the 400 to see if any of the factors have perfect squares. Well, with 400, we know that 4 is a perfect square, and we can multiply that by 100. From 100, we know that 4 is another perfect square, and we have 25, which are all perfect squares. Therefore, 400 actually is a perfect square. Let's look at the 400 first before we go into the variables. With the square root of 400, we have 4 multiplied by the square root of 4 multiplied by the square root of 25, and then what's remaining is our x cubed y squared. So the square root of 4 is 2, the square root of 4 is 2, the square root of 25 is 5, and then we have the square root of x cubed y squared. 2 times 2 is 4, 4 times 5 is 20. We know that 400 is a perfect square because its value is 20. However, we're still left with the x cubed y squared. When dealing with variables under the radical, all you need to do is remember your exponent rules, which again I have in the description below if you need a refresher. The easy thing to remember if we're dealing with a regular square root is to subtract 2 from your exponent, and when you subtract 2, you can move it outside, because remember, x times x is equal to x squared. So to get this value of x, all we need to do is remove 2 from the exponent. With that, we have x squared times x. This x squared drops out and becomes x. So 20x, and we still have the square root of x left. And then we still have the y squared. Well, y squared is y multiplied by y, right, which equals y squared. We know that y is the value of the square root of y squared. We can bring that outside. And now we are left with just x on the inside. Before we say this is the correct answer, we need to remember that it's plus and minus. And once we have the plus and minus, we can say that this is the correct answer. If you want to check your work, all you need to do is take 20xy square root of x squared. And with that, we have 20 times 20, which is 400. X times x is x squared. Y times y is y squared. And then the square root of x multiplied by the square root of x is x. We simplify this and we get 400 x to the 3 y squared, which looks like our original equation. There you go. If you learned something, please like and subscribe. If you have any questions, leave them in the comments below, and we'll see you next time.